Take this piece of paper, fold it in half. Okay, take that. Notice it's folded hamburger. Then fold it again. Got that. At the very top, we're going to write Sine Transformations. And we're going to do some stuff on the back.
Sine Transformations is about analyzing the sine or cosine function before graphing. Now, I want you to write this at the very top of your page. We're going to split apart this page into 4 columns and analyze 4 of the parameter transformations on sine. First one is amplitude. Amplitude is simply the distance from the oscillating axis to either the maximum or the minimum. Same thing. On the far right, I want you to write, on the far right column, I want you to write vertical translation. Now that goes with the D, and it's the vertical translation from the original x-axis to the new oscillating axis. An oscillating axis is the axis by which a sine wave oscillates about. That's the D. Okay, before we continue with phase shift and period, go ahead and turn your page over to the back and write this formula. Note that the angle, what was x, is now being changed by bx minus c. So whatever's coming in here has to go through this process, and then it comes out. Now the out process has to go into sine, and then sine gets multiplied by a and then added by d, and becomes the function. Now there are some things that are fairly simple when dealing with this, and that has to be the d and the a. Because whatever the sine has output, it's going to be multiplied by a. It's going to change its amplitude. Then the D makes that oscillating axis shift up. But the hard part is dealing with that angle. Notice if we're talking about the sine wave, we're saying that the beginning is 0 and the end is 2 pi. Those are the 2 key values from the unit circle where we go around. So sine, the important values are 0 and 2 pi. So what we do is we take this argument, this input, and we set it equal to 0 and to 2 pi, and solve for x to create our new beginning and end points. Alright, so let's go ahead and do that. So we've got our bx minus c is equal to 0, and we've got our bx minus c is equal to 2 pi. If I solve each of these for 0, get this. Now, note that the beginning value, the new beginning value, remember beginning value because this starts with 0, and this is the ending value because this starts with 2 pi, given that the sine wave starts and stops on the axis. This is the original sine wave. We're now starting at c over b, and we're ending at 2 pi over b plus c over b. Note that the only difference between these two is this 2 pi over b. Now, if this is the ending x value, and this is the beginning x value, notice that if we subtract these two, we get a period. We can find the period, and that is the difference, which is 2 pi over b. So these two values tell us that 2 pi over b is the period. But our new beginning value is c over b. So let's go ahead and go back to our table, or excuse me, our front side, and let's go ahead and mark up our other values. Notice we're looking for the period. The period is the distance between beginning and ending points. And it's 2 pi over b, just like you saw from the formula I derived from the back. And that's when this sine wave starts and stops and begins again. All right, the phase shift is the horizontal translation, but it encompasses more of an idea than that. Because a phase shift, notice b is part of the process, which means the period is being changed too. So not only is it changing this horizontal value, but we say it phase because it has an effect on the actual period. But the period is still 2 pi over b. So the period is still 2 pi over b, but the phase shift is the thing that's changed. All right. So what? Well, the whole point of all this is that you have a familiarity with analyzing sine and cosine functions so that you can graph them and apply them to different situations.